So the big rule here is the product rule, right? We're multiplying two things. This thing times this thing. Okay? So when we derive that, the product rule says derive one, leave one. Doesn't matter which one you want to derive first. I derive the first thing first most of the time. So the derivative of sine of something is cosine of that thing. But because what's inside is not x, we do the chain rule and multiply by that. And then we multiply by the second thing. Second function. Everybody hear that? Now plus, now we leave the sine of x squared and we derive 3 to ln x. But the derivative of 3 to a power, that's an exponential thing. So the derivative of that is ln to the base times the same exact thing. But because what's up in that exponent isn't just an x, we're going to multiply that by the derivative of the exponent, which is 1 over x. So that's that. Okay, here's number 2. So, the big rule here, you can definitely see a quotient rules in there, right? That's a big old fraction. Let me do the quotient rule. But that quotient, for inexplicable reasons, is inside of a logarithm. Okay? So we have to derive the log first. Okay? And the derivative of a logarithm, as much as this hurts, as terrible as it is 1 over ln of the base times the same thing that is in there. It's really 1 over ln to x, right? But if there's something weird inside the log, that's what happens. We get that? That's just the log rule. Now we're going to multiply that by the derivative of what's inside, which is the chain rule. But what's inside happens to be a quotient. And you're like, oh, no, but the quotient rule ain't too bad. I'll put a big bracket. You can use parentheses. I like brackets. Sometimes it separates it out, makes it look a little bit easier to identify. All right? But the quotient rule says we're going to, remember low d high, right? Low d high. So low is cosecant. D high is just 2x. That's easy. Minus. High d low. So if one of these has more than one part, like the top, the high function, the function, the numerator, is x squared plus 1. When you write that, you got to put it in parentheses, like the whole thing's there. All right? So just put that in parentheses there. And that's times the derivative of the denominator, low, d low. That's cosecant, so the derivative of that is negative cosecant x cotangent x. So you can write that here, negative cosecant x cotangent x, but once I know I'm multiplying by negative and there's this big minus here, that just makes this a plus. You can just write it like that. There's nothing wrong with putting the negative cosecant cotangent there and putting in parentheses at the end. That's the same thing, but it does make it a big plus. And that's all over the denominator squared. Look at that nasty thing. There you go. Well, this is, if you see, right, it's a big chain rule. The function and a function and a function. So the derivative of this bad mamma jamma, you always derive the outside first, right? Guys, if you're ever unsure about what's going on too, like plug a number in here. Like if we plug 2 into here, we would cube it first. Does that make sense? We would get 8 cubed, or 2 cubed. Then we would take the arctangent of it. So these are the functions we have to derive. Cubed. Then we would take the arctangent of it. Then we would take the square root of that. You see that? That's the order that would happen. So the chain rule says we derive that backwards. You always derive from the outside in. So we derive a square root first. And the derivative of a square root is 1 over 2 square root of x, really. But if there's something weird in there, like an arctan of x cubed for some reason, that's that. Okay? That's deriving the square root. Then you pretend the square root's not there, and you derive what's inside the square root, which is arctangent. And the derivative of an arctangent is 1 over 1 plus what's inside squared. So it should be x squared there, but it's really x cubed squared. And x cubed squared, by the way, kids, just so we look at our exponent rules, is x to the 6th. You multiply those. that okay? Then we're going to multiply that by the derivative of what was inside the arc tangent, which is x cubed. So our options are, we can put a big old parenthesis here and put a 3x squared here. If you are cramped for space and running off the edge of the paper because I've made these too big, you could put a 3x squared up here. That's the same thing. Okay? So this is definitely a big quotient rule, which says low, which is e to the cosine of x, right? Low d high. So we're going to drive the top. Here's something maybe like you wouldn't think about, or maybe you do, I don't know. But because the numerator is going to need the product rule, you've got to put that in parentheses. So sometimes what I'll do is I'll put like a bracket, just so I know that's low and d high is going to be in these brackets here. All right? But the product rule says derive 1, leave 1, plus, leave the first, derive the second. And because the derivative of cotangent is negative cosecant squared, you can write that like that. Or you can also turn this plus into a minus and leave it like that. That's the same thing. All right, but I'll leave it like this just so if you look on the answer key, you can see what's going on there. So that's low d high. Then minus high. You can put that in parentheses, but you don't need it. Parentheses definitely need to be had if there's like a plus or minus in there. You got to lump them all together. But multiplication's already together, so that's fine. So we're going to derive the denominator, the left. And the derivative of e to a power, we just saw this, is e to the same power times the derivative of that exponent. So that's that. All over, low squared. And again, if you square something that has an exponent, you're really just going to multiply that exponent by 2. That's what that does. So you can write it like that right there, or you write it like this. But it's not cosine squared. It's e to the cosine the whole thing squared, or e to the 2 cosine of x. All right. Hopefully not too bad. P prime, so this is an arc sine of something, so the derivative of arc sine of something is 1 over the square root of 1 minus that thing squared. And e to the x squared is the same thing as e to the 2x. And you're going to multiply that by the derivative of what's inside, which is e to the x. So you can either put that out here like this, okay, so times, or you can put it on top of here. That's the same thing. So that's that one, not too bad. So this is just product rule. And we're going to do f prime of x, derive 1. So I derive the first, but again, it does not matter the order in which you do this. Plus, leave the x squared and derive the arc secant of x, which is 1 over the absolute value of x times the square root of x squared minus 1. All right. And because there's an absolute value in the x down the bottom, like we can't really cross out the x's. Sometimes, like on a multiple choice test, you don't see the absolute value there, and that happens because x has to be positive already anyway in that particular problem. But so if you write it, you should put the absolute value there. All right. But if you see a multiple choice and it's not there, they're not trying to trick you. There's a reason why it's not there probably. What's up, Ben? Yeah, dude. All right. So we have 3 things being multiplied, which we do here. It's not really anything super scary. The product rule says you derive 1 and leave the rest. Okay? So you could think about like this being times arctan and derive that times arctan plus derive arctan times that. Okay, you can go that route. Or it's really just this happening. Look. If you have more than 2 things being multiplied, you derive 1 and leave the other 2. Plus, derive the second one and leave the other 2. Plus, derive the third one and leave the other 2. That's going to be this. All right, y'all. Let's talk about 8. This is just the product rule, right? Because we've got arc cosine times, which is different than arc cosine of something. It's time, arc cosine of x times something. So h prime is, derive 1. It doesn't matter which one. I'll derive arc cosine first. That's negative 1 over the square root of 1 minus x squared. Oh, okay. Wow. Cool? Plus, and yes, you can put the log right on top of that, okay? This is the same thing as this. No, you don't have to do that right now, but it is the same thing as that. Plus, leave arc cosine, derive log base 5 of x, but that's 1 over ln 5x. There you go. Okay. This is the chain rule. We have an ln with something inside of it, right? That's our big rule here, right? It's not multiplied or anything. Come on, young adults. G prime is 1 over ln of e, that's base e, but that's 1, times what's inside. That's the first thing. Then we're going to chain on the derivative of what's inside of the ln, which is something in a cubed root. And the derivative of a cubed root, which is really 1/3 power, when you derive that, it's 1 over 3 x to the 2/3. So this becomes 1 over 3 tangent of x to the 2/3. Then we're going to multiply that by the derivative of what's in the cubed root. That's a tangent. And the derivative of tangent is secant squared of x. Okay, now, something interesting. What's up, Daniel? Well, we're going to combine, we're going to simplify it. So this, if you leave it like this right now, that's fine. But check this out. You see we have tangent to the 2/3 right here on the bottom, and we're multiplying that by cube root of tangent, which is tangent to the 1/3. You guys see that we have tangent to the 1/3 and tangent to the 2/3. They're being multiplied. So it's really tangent to the 3/3. Is that okay? Maybe? So it's really secant squared on top over 3 tangent of x. Is really what that is. Yeah? I can't hear you. What?
Because the derivative of the outside is 1.
Here we go, kids. Are ready? Hang on, Julian. Sorry.
I'm not sure if this is the same question as Cho asked, but why is it the tangent derived to set what is inside the
You derive one function at a time, and you derive the outside function. So the first thing we derive is ln. Everything else stays the same. Then we derive the cubed root. Tangent stays the same. Then we derive tangent. Okay?
Yeah, I derived the tangent of the cube root.
Now let me show you something else too. Another way we could attack this. Look, do you all know that this is ln of tangent of x to the 1/3 power, right? Are we okay with that? That's the same thing. A rule for logarithms, which we've been over, which could simplify things for us, is if you have a logarithm of something to a power, you are allowed to bring the power down to the front. That's not the derivative. That's just a rule for logs. They're equal. So if I derive that version of it, check this out. G prime of x is 1/3, because the 1/3 is just there. Just leave it. Then we derive ln of tangent. Ln of tangent is 1 over tangent times the derivative of tangent. And you can see this is exactly the same thing as this without having to go through this step. So if you use your log rules first, it makes it a little bit simpler. Okay? All right, y'all. The derivative of an exponential is ln of the base. That looks like that, but you don't need that because ln of e is 1. What's the ln of e? 1, yes, you don't need that. It's there, but it's 1. Times the same thing, and then times the derivative of the exponent. That's the chain rule. Good, but don't write ln of e because later on we're going to be simplifying this and it's going to be complicated looking, and the ln of e is 1 and you should know that. All right. Yo, stick with me, make sure you got all this. We're driving log base 4. The derivative of log base 4 is 1 over ln times x to the 4th plus 1. You need parentheses around that. Then we're going to multiply that by the derivative of what was inside. That goes right here, or you can put it on top of the fraction. Times the second thing, arc sine or sine inverse, same thing. Plus, leave this alone, log base 4. There you go. Okay, this is the product rule. We can drive the secant first. That's secant of what's inside. Tangent of what's inside. Then derive the inside. That's the derivative of this. Okay? But we're doing the product rule, which says then multiply by the other plus leave the first, derive the second. The derivative of ln of x is 1 over x. You can put it just like that. You can also chain it on the end and have times 1 over x. It's the same thing. Okay?